Hi everyone, this is Dr. Nuck, and today we're going to be learning about the applications of quadratic equations. So pretty much this section is all about word problems. Don't hate. We can do this together. Let's first review the ways that we can solve quadratic equations. Again, quadratic equations are equations of the form ax squared plus bx plus c equals to 0. So method 1, factor. Method 2, apply the square root property. 3, completing the square. And then choice number 4 would be applying the quadratic formula. Now, since we're dealing with a bunch of word problems in this section, in order to get there, meaning to set up the quadratic equations, first, of course, we need to read the problem. And then step 2 would be identify what we're looking for. And step 3, name what we're looking for. Like maybe let x equals to my age, y equals to your age, and such. And then step 4 will be translate into an equation. And then step 5, of course, solve. Then that's when you get to use all those choices 1 through 4. Anyways, I think the best way to learn this section is doing a bunch of examples. So let's get started. Example 1, the product of two consecutive even integers is 168. Find the integers. So there are a couple things going on here. So first we need to understand what the heck is two consecutive even integers are. And then we also have to know the definition of a product. So let's do the easy one first. The product means multiply. So make yourself a note. So this means multiply. Now let's talk about two consecutive even integers. So let's see, 4 is even, isn't it? So if I let 4 be the first even number, then the next even is 6, next one is 8, 10, 12, yada yada yada. Okay, so now let's see the pattern. If I start from 4, and then if I have to go to next one, next even number, how many do I need to add? 2. And then from 6 to 8, because 6 is even, the next one would be 8. How do I get there? Well, if I add 2 to 6, I can get to 8. Now, the consecutive means that following one after the other in order. So if I talk about two consecutive integers, even integers, if I start from 4, the two consecutive would be 4 and a 6. Now, 3 consecutive even integers will be 4, 6, and 8, and so forth. So let me just let n be our first even number. So pretend that n is 4. Now, how do I get to the next even number? Next even number is 6, isn't it? So starting from 4, if I add 2 to it, I could get to the next even number. So n plus 2 represent the second consecutive even number. Now, if I ask you, find the 3 consecutive even integers. Okay, so let's talk about that one. So if I start from 4, I want 3 consecutive even integers. So basically, if I start from 4, I want 8. So how do I get there? Well, if I add 4 plus 4, then I could get to 8. So in this case, if our n is 4, then if I add 4 to it, then we can get to 8, which will be our third consecutive even number. All right, keep that in mind, and I think we're ready to do this problem. So first, we need to reread it again. It says the product, the multiplication of two consecutive even integers is 168. Find the integers. All right, so first I'm going to write it like this. Let n be our first even integer. Now, we just want two consecutive even integers. So if I express the second one as n plus 2. I think that makes sense. Therefore, n plus 2 would be the second consecutive even integer. Now let's find out what the question's asking us to find. It says that find the integers. So what we want is the value of n and then the value of n plus 2. So let me just box what we want. So these are what the quantity that we need to find out. Okay, so I think we're ready to set up the equation, so let's do it. So it says the product of two consecutive even integers is 168. So what's the first even integer? That's n. Product means multiply. And then the second consecutive even integer is defined by n plus 2. Now if I multiply these together, it better multiply to 168. Now from here, what we need to do is we're going to have to set up the quadratic equation and just solve for n. Alright, so first what I'll do is I'm going to distribute the n to n plus 2 to get n squared plus 2n equals to 168. And then I want to bring the 168 on the left hand side, so I'm going to subtract 168 to get n squared plus 2n, and then minus 168 equals to 0. Alright, so looking good. So is this factorable? I think so, so let me see. If it doesn't factor, we'll try something else, and that's all. Alright, so we got n and then n. Now, those of you who use this, the diamond method, I will just write negative 168, and then middle number is positive 2. So the sign better be either positive or negative, because when I multiply those two side numbers, it has to multiply to negative 168. So that means that for sure I need to have one positive, one negative. Now, let's talk about the decomposition, or I should say, let's find the side numbers. How about, is it 168? Is it same thing as 14 times 12? I think so. So if I put a positive 14 and then minus 12, this is going to multiply to negative 168, and then if I add those two, I get positive 2. So this is perfect. So we're going to put n plus 14 and then n minus 12 equals to 0. Alright, so that implies that n plus 14 is 0, or n minus 12 is 0. So this means that n is negative 14, or n is 12. Okay, so let me just box this. Okay, so great. We found the value of n, but what does n stand for? Let's go back to what I boxed earlier. Well, n is one of the quantity that what we're looking for. N is the first even integer, and the second consecutive even integer formula is given by n plus 2. So let me just spell it out. So n is the first even integer, so that's either negative 14 or 12. So the second consecutive even integer, all you have to do is add 2 to negative 14 and then add 2 to 12. Let's work on the negative 14. So the second consecutive even number, remember the formula was given by n plus 2, wasn't it? So n plus 2, so that implies that our value is going to be negative 14 plus 2, so which will give us negative 12. Alright, now let's go to the other side. If the first even integer is 12, then the second consecutive even integer will be what? You just add 2 to it, so it will be 14. So we're going to do the same thing. The formula for the second consecutive even integer is n plus 2, but our n was 12, so if I add 2 to it, we're going to get 14. Now, since this is a word problem, our answer should be in a sentence. So this is what I would write. So therefore, two consecutive even integers whose product is 168 are, let's see, the first set is what, negative 14 and negative 12, and maybe 12 and 14. So I'm just gonna box these two for the answer. Now let's look at something like this. Example 2, an architect is designing the entryway of a restaurant. She wants to put a triangular window above the doorway. Due to energy restrictions, the window can only have an area of 120 square feet, and the architect wants the base to be 4 feet more than twice the height. Find the base and height of the window. What a picky architect. But anyways, let's get started on this, and do not be afraid of word problems. All you have to do is determine what we're looking for and translate the important portion of the word problem. So let's first determine what the question is asking us to find. So let's look at the very last sentence. It says find the base and height of the window. Okay, so let me just box that. So what we want is base and a height of the window. Also remember that our window is going to be triangular. Now let's just jot down what's important. Well, we're talking about the triangular window. So first, let me draw that picture. And let's pretend that this is the window that the architect wants. Now, what is other important information? Well, let me see. The window can only have an area of 120 square feet. So let me make myself a note. So the area must be 120. Now, what's the next important phrase that we can find? The architect wants, that's not important, the base to be 4 feet more than twice the height. So let me just underline that. We need to have a base to be 4 feet more than twice the height. Now, since we're looking for the base and the height of the window of the triangle, so let me just denote. Let B stand for the base, and then H stand for the height. And what we want is B and a H, the value for B and a H. Okay, now let's translate base to be 4 feet more than twice the height. So I'm going to bring this phrase down here. All right, ready? So base must be 4 feet more. Okay, so let me just start with B must be, so B equals 4 more than twice the height. So 4 more than, that's 4 plus, isn't it? Twice the height. So how do we write twice the height? That would be 2 times the H. Therefore, we have this equation B equals 4 plus 2H. And the area must be 120. Now, I'm going to label this picture, so the base will be here. B is on the bottom. And then from here to here will be the height of the triangle. Now, to find the value of B and H, since we're giving an area to be 120, we need to use the formula for an area of a triangle. So let's review that real quick. So remember the area of a triangle. Remember the formula? Is 1/2 base times the height. So you might want to memorize that if you forgot. So let's plug it in what we got. Since we know that the formula for the area of the triangle is A equals 1/2 B times the H. But are we not given the area? I think we're given the area, no? So area is 120, so I'm going to replace our A with 120 equals 1/2. Now, base is given by 4 plus 2H. So I'm going to replace that. 4 plus 2H Do you see that? So this b is here. How do I find that? This equation right here. We already know that b equals 4 plus 2h. So in place of b, what I just did was replace it with 4 plus 2h. And then you still got the height h. Now let's try to simplify this a little bit. So we have 120 equals, let me just first distribute the 1/2 to this, and then we'll multiply everything by the h. So if I do that, then here what we're going to get is 4 divided by 2, which will be just 2, plus 2h divided by 2, which will just give us h, and then we're going to multiply that by h. Alright, so then we get 120 equals 2h plus the h squared. Okay, so now I want to form a quadratic equation, so what I'm going to do is this. Let's bring that 120 on the right hand side. So if I do that, then I'm going to subtract 120, subtract 120. Now I'm going to rewrite this as 0 equals h squared plus 2h, and then minus 120. Okay, so from here, I think we're able to solve for h, so let's do it. So is this factorable? I believe that it is, because we're going to have 0 equals, let me just put 2 parentheses here. Better have a h and a h, sign better be positive, negative. How about if I had a positive 12 and minus 10? Would that make sense? So first term, if I multiply that out, I get h squared, and then negative 10h plus 12h will give us a positive 2h, and then multiplying by 12 and then minus 10, we get a minus 120. So it works. Alright, so now that implies that either h plus 12 is 0 or h minus 10 is 0. So then if I keep simplifying this, we're going to have h equals to negative 12 or h equals to positive 10. Alright, now let's just stop here for a minute. What does h stand for? So h stands for the height of the triangle, right? So look at it. Which one does not make any sense? Yeah, height cannot be negative, so we need to throw this one away. Bye-bye. So this does not make sense. So what we're going to do is we're just going to keep our height to be 10 feet. Now, given that, how do we find the base? Well, look over here. Let me see. This is the formula for our base, isn't it? So here, I'm going to rewrite it as like this. Since b equals to 4 plus 2h, but we just discovered that h is 10. So that implies that b equals to 4 plus 2 times 10. So base must be 4 plus 20. So our base is 24, it looks like. So our answer is going to be, so therefore, our base of the triangle is 24 feet, and the height of the triangle is 10 feet. And that's going to be our answer. Now let's try something like this. The length of a 200 square foot rectangular vegetable garden is 4 less than twice the width. Find the length and width of the garden to the nearest tenth of a foot. So for this particular problem, at the end, we're going to have to use a calculator because they're asking us to round our answer to the nearest tenth. But on the exam, since you're probably not going to have a calculator, just leave your answer in exact form. So first, let's jot down what the question is asking us to find. Alright, so it says that find the length and the width of the garden. Now, which garden is nothing but a rectangular form? So this is rectangle. Now, I always like to draw a picture just so that I can understand what is going on. So let me do that real quick. So here is the picture of the rectangular vegetable garden, just a rectangle. Now let me just call, since we're looking for length and width, so let me just, doesn't matter which one you want to call length and width, but let me call this one the length. Length is denoted by L, and then width, I'm going to denote that by W. So let's write that down. So let L be the length of the garden, or length of the rectangle, and then W to be the width of the rectangle. Now what we want is L and a W, so I'm just gonna box what we want, and let's reread the problem. It says that the length of a 200 square foot rectangular garden. So first of all, do you see that we're given the area of the rectangle? Area of the rectangle we're given to be 200 square foot. So let me just write that out. Okay, so we know that the area is 200. Now let's reread the problem. The length of a 200 square foot rectangular vegetable garden is, so L equals 4 less than twice the width. So let's translate that in a mathematical notation. So I'm going to bring that over here. So the length of a rectangular form is 4 less than twice the width. So we're talking about L length is 4 less than twice the width. Now, how do I write twice the width? Twice the width means, isn't it, 2W, right? And then 4 less than that. So our L, the length, must be 4 less than twice the width. So that will be 2W and then minus 4. So that is the key equation. Since we're given the area of the rectangle, let me just write down the formula to compute the area of the rectangle. So area is given by length times the width. All right, now A is 200, and then our L is given by 2W minus 4. So I'm going to replace that with 2W minus 4, and then multiply that guy by W. Okay, so now I think we're good to go. So we got 200 equals, I'm going to distribute that W to get 2W squared and then minus 4W. Now let's bring that 200 on the left hand side. So if I do that, then I'm going to get, let me see. We're going to have 0 equals 2W squared minus 4W and then minus the 200. Okay, so maybe this is factorable, but first let me get the greatest common factor out of here. So the greatest common factor will be 2, isn't it? So I'm going to factor out the 2 and then rewrite this as W squared minus 2W and then minus 100. And I don't think we can factor that. So let's choose our next favorite weapon. Which one is your favorite? Mine will be the quadratic formula. So let me just take this equation here and I'm going to apply the quadratic formula. So here, I'll just write it out. So in this case, our A is 2, B is minus 4, and then C is minus 200. All right, so we're gonna have our W equals 2. Instead of an X, we have a W. I'm gonna have minus B plus or minus the square root B squared minus 4AC, whole thing dividing by 2A. So let's follow the formula. So you're gonna have negative 4 plus or minus the square root of negative 4 whole quantity squared minus 4 times 2 times minus 200. And then whole thing over 2 times A. So you're going to have 2 times 2. Let's keep going. So this is 4 plus or minus the square root of 16. And then you have 4 times 2 times 200. And then we have 2 negatives. So we got, what is that, 1600? All right, whole thing dividing by 4. So we're going to get 4 plus or minus the square root of 1616, whole thing dividing by 4. Yikes, no wonder XYZ wants us to use the calculator for this because of that square root. But I'm going to work this as a side work, so let me see. You know what, since I'm running out of room, let me just try to squeeze it in here. All right, 16, 16. Of course, it's even. 2's going to go in, so you got 2 times, what is that, 808? And then 2 times 404. And then 2 times, what is that, 202? 2 times 101. Okay, so I'm just going to stop right there. So here, 1616 is 2 to the 4th times 101. So the square root of 1616 is square root of 2 to the 4th times 101. So you got square root of 2 to the 4th is same thing as 2 squared, which is going to be 4, times the square root of 101. Nasty. All right, so you know what? Since I'm running out of room, I'm going to bring this on this side. Hopefully you can follow my work. So now what do we got? So we have 4 plus or minus 4 square root of 101, whole thing dividing by 4. So this is same thing as 4 over 4 plus or minus 4 times square root of 101 dividing by 4. So simplify, 1 plus or minus square root of 101. So that implies that our width is either 1 plus the square root of 101, or our W can be 1 minus the square root of 101. Okay, now let's just look at the square root of 101. 101 is very close to 100, isn't it? So what's the square root of 100? Yeah, that's 10. So which one does not make sense? So W equals to 1 plus almost 10, and then another W is 1 minus almost 10. So do you see that this side is not going to work out because we're going to get W to be a negative quantity. So we need to throw that one out. So guess what? We get to keep our W to be 1 plus 101. And then how do you find the length? Well, let's go back to the formula that we wrote earlier. So I'm just going to have to cut through like this. Whoop. All right, so here is the formula for the length. So since our length is given by 2W minus 4, we're going to have 2 times W is 1 plus the square root of 101, and then minus the 4. So here, I know it looks so gross, but we got this. So here we're going to get 2 plus the 2 root 101 minus 4. So what is that? 2 minus 4, we can combine 2 minus 4 to get minus 2 plus 2 square root of 101. So let me just box that in red. Okay, so don't freak out because there's a negative 2 in the front of it, because look, square root of 101 is almost equivalent to square root of a 100, which is going to be 10. So pretend that square root, we got the square root of 100. Then you're going to have not minus 2 plus 2 times the square root of 100, which is 10. So basically we got 20 minus 2, which will give us positive value of 18. So this makes sense. So I'm going to answer this as, therefore, our length of the garden is minus 2 plus 2 square root of 101, and then our width is 1 plus the square root of 101. This is the reason why XYZ asked us to use the calculator, but here what I did was I just worked everything by hand. So if you wanted to, you could just stop to here and you can use the calculator from here. Alright, but anyways, we're done with this problem. Let's take a look at something like this. The sun casts a shadow from a flagpole. The height of the flagpole is 3 times the length of its shadow. The distance between the end of the shadow and the top of the flagpole is 20 feet. Find the length of the shadow and the length of the flagpole. Round the answer to the nearest tenth. Okay, we can do this. So first, let's find out what the question is asking us to find. So let's go towards the end. It says find the length of the shadow. So what we want is the length of the shadow and the length of the flagpole. So first, let's draw a picture so that we can understand what the heck is going on. Look at that beautiful picture. I'm actually proud of myself. Alright, but anyways, I was gonna draw American flag, but I couldn't because the flag is a little too small for me to fill in, so I just put a Japanese flag right there. But anyways, so hopefully you can tell that this is a flag. And then this is my sun, by the way. It looks like a sun, isn't it? Alright, now the sun is casting a shadow, so that our shadow is right here. So this is the shadow. So let's give a variables to what we're looking for. So first I'm going to say let L be the length of the shadow. So that means that this length from here to here is going to be our L. And then I'm going to say let H be the length of the flagpole. Alright, so that means that from here to here is our H. Now let's underline some keywords. Okay, so it says that the height of the flagpole is 3 times the length of its shadow. So I'm going to say the height of the flagpole is means equals 3 times the length of its shadow. Alright, so what are we given here? Height of the flagpole, we denoted that by H. So we're given that, so let me just bring it over here. So we're given that H is 3 times the length of its shadow. So do we name a variable for the length of its shadow? Yes, that's L, isn't it? That's our L. So let me just read it again. Height of the flagpole is, so H equals 3 times the length of its shadow. So it should be 3 times the length of its shadow. So we now have the key equation of H equals to 3L. So this length right here is going to be 3L. Now let's pick out another important information. It says that the distance between the end of the shadow and the top of the flagpole is 20 feet. So the distance between the end of the shadow, so that will be where? It's right here, isn't it? So this is the end of the shadow. And the top of the flagpole. So the top of the flagpole will be right here. Sorry, that says top of the flagpole. I hope you can read that. Now that distance is 20 feet. So guess what? The distance from here to here is 20. I think we now have all the information that we need to do this problem. So let me just box what we're after. So we're after L and H. Now to do this problem, we need to use the Pythagorean Theorem. Now the Pythagorean Theorem says that given a right triangle, our hypotenuse, which will be c squared, better equal to a squared plus d, b squared. Please memorize the Pythagorean Theorem. Now, instead of our little letter a, by the picture, that stands for our L, which is the length of the shadow. And then our little b here is nothing but our height, which is 3L. And then the hypotenuse is given by 20. So this is the situation. All right, so now we're going to apply the Pythagorean theorem to this. So we have hypotenuse squared, which will be c squared. Let me just write it as c squared equals to a squared plus the b squared. So in this case, we have L squared plus h squared. Now, since our c is 20, so let me just write it. In this case, we have c equals to 20. So if I apply the Pythagorean theorem, what we're going to get is c squared, so which will be 20 squared equals L squared. And then plus the h squared. But what's our h? H equals to 3L. So I'm going to replace our h with 3L. Okay, so you're going to have L squared plus the 3L. All right, I think we're good to go. So let's just compute. 20 whole quantity squared is 400 equals to L squared plus 3L. Now let me subtract 400. So we now have 0 equals L squared plus 3L minus 400. Now I don't feel like factoring this, so what I'm going to do is apply the quadratic formula. So let me just write that formula out. So I'm gonna apply quadratic formula. Alright, so here what we're gonna get is L equals minus b plus or minus the square root of b squared minus 4ac, whole thing dividing by 2a. So in this case, our a is 1, b is 3, and then c is negative 400. All right, now plug and chug. So we got L equals minus b, so minus 3, plus or minus the square root of 3 squared minus 4 times a times c, whole thing dividing by 2a. So 2 times 1 is just 2. But anyways, let's keep going. So this is same thing as minus 3 plus or minus the square root. 3 squared gives 9, and then the rest of it is just 4 times 400, 1600, whole thing divided by 2. So here this is going to turn into minus 3 plus or minus the square root of 1609, whole thing dividing by 2. Alright, no wonder they want us to use the calculator for this. So for this particular problem, I'm going to use the calculator. Now before I punch this in the calculator, you know what, I'm just going to box that. Let's bring it over here because I am running out of room. So this implies that either L, which is the length of the shadow, is minus 3 plus the square root of 1609 dividing by 2, or our L is negative 3 minus the square root of 1609, whole thing divided by 2. Alright, so if you type this in the calculator, the first one with the plus in the middle, L is approximately 18.55617. And then if I plug this guy, the second L, this is going to be approximately negative 21.6. So in this case, since L stands for the length of the shadow, can the length ever be negative? I don't think so. So, bye-bye. We toss that one away. So it looks like our L is approximately going to equal to 18.6. So here is the length of the shadow. Now let's go with the H. So we also need to compute the length of the flagpole. So how do I find it? Well, go back to that magical equation that we got from the very beginning. So our H formula is given by at the very top of the, right next to the picture, the triangle picture. So our h is 3 times L. So this is going to be approximately equaling to 3 times 18.6, which is 55.8. So let me box that. So it looks like, therefore, the length of the shadow is how many feet? 18.6 feet. This is approximate value though. And then also the length of the flagpole is 55.8 feet. So this is going to be our final answer. Hopefully you can read my handwriting okay. So here it is. That's our answer. Now, before we go over the next example, we're going to have to know this formula. The projectile motion, it says that the height in feet, height is denoted by h, of an object shot upwards into the air with the initial velocity. The notation is v sub 0 after t seconds is given by h equals negative 16 t squared plus v sub 0 times t. Now let's take a look at example 5. A firework is shot upwards with an initial velocity of 130 feet per second. How many seconds will it take to reach a height of 260 feet? Round to the nearest tenth of a second. Now let's first jot down what the question is asking us to find. So it says that the second paragraph, how many seconds would it take to reach a height of 260 feet? So how many seconds? So we're looking for the time. So I'm going to write it as how many seconds to reach the height of 260. So here I'm going to denote, let t equals the number of seconds. And this is what we're looking for. We need to solve for t somehow. Alright, now let's digest the problem. Let's first write down the formula for the projectile motion. So h equals negative 16 t squared plus v sub 0 times t. Now, what else are we given? Well, the height of 260 feet. Right? Also, the initial velocity, I should change the color on that. The initial velocity of 130 feet per second. So here, what we're given is that initial velocity, v sub 0, is 130. And then the height, which is h, equals to 260. So those are the important information that we need to use for this problem. Okay, now let's plug it in. So since our height is 260, I'm going to replace our h with 260 equals to minus 16t squared plus v sub 0 is 130 and then times t. So now let's bring that 260 on the other side by subtracting it. So then here you're going to get 0 equals negative 16t squared plus 130t and then minus 260. Okay, so now I'm going to apply the quadratic formula to this. So let me just write down, I'm going to write it as quadratic formula. So our t is going to be minus b plus or minus the square root b squared minus 4ac, whole thing dividing by 2a, where a is negative 16, b is 130, and then c is minus 260. Okay, we can do this. So ready? So t equals minus b, so it's minus 130, so that's a minus, sorry, and then plus or minus the square root of 130 squared minus 4 times a times c whole thing dividing by 2 times a. So you got 2 times a. Okay, let's keep going. So we got t equals minus 130 plus or minus, okay, I'm just going to use my calculator on this portion. And if I type that in the calculator, I got our discriminant to be 260. Now, whole thing dividing by 2 times negative 16, which is negative 32. All right, so now let's split up the t. So we got either t equals negative 130 plus the square root of 260 whole thing over minus 32, or our t is going to be minus 130 minus the square root of 260 whole thing dividing by negative 32. So here, oh goodness, let's use the calculator to get two values for t. So I got the left hand side of t to be approximately, so let me just put approximate, 3.558, so that will be 3.6. And then on the other side of t, I got 4.56639, so t is approximately equal to 4.6. All right, so I'm gonna box that for the answer. Now let's translate. What did t stand for? That's exactly what we wanted, and t is the number of seconds. So to answer this question, we could say that the firework will go up and then fall back down for sure. And as the firework goes up, you'll reach 260 feet after approximately 3.6 seconds. And then it will also pass that height on the way down at 4.6 seconds. So let me just try to write that down. And I'm gonna box this long story as our final answer. Okay, now let's take a look at an example like this. It says that Dr. Nak just got back from a boring conference that was 4,000 miles east of her home. Her total time in the airplane for the round trip was 10 hours. If the plane was flying at a rate of 450 miles per hour, what was the speed of the jet stream? And before we do this, we're gonna have to know one formula, and that formula is called a formula of motion. So let me write that out. The formula of motion says distance equals rate times time. And a lot of people memorize this as d equals rt. So to do this problem, we're going to have to use that formula. But let's first jot down what the question is asking us to find. Towards the end, it says, what was the speed of the jet stream? So that's exactly what we're looking for. So I'm going to start off with let r equals the speed of the jet stream. Now let me draw a picture just so that I can understand better of what the heck is going on. Okay, so since we are talking about the round trip, I'm gonna go first to the conference and then back home. Now let me draw the jet stream. So suppose that this is my jet stream. And suppose it's pointing towards the right. So if this was the case, on the way to the conference, I am traveling with the wind. Now on the way back home, I'm gonna be flying against the wind. So let's just fill in what we're given here. Now, the total distance was how many miles? 4,000 miles. Okay, so from here to here, it's 4,000 miles. And what else are we given? My total time in the airplane for the round trip was 10 hours. So let me just change the color. So starting from here, all the way back home. So this portion was 10 hours. And on the way to the conference, I am traveling with the wind. So going this way, I'm going with the wind. And going this way, I'm traveling against the wind. Now, when the plane flies with the wind increases its speed. Well, how much faster? Since the plane is flying at the rate of 450 miles per hour, on the way with the wind, you're going 450 plus the speed of the jet stream. So the total rate is going to be 450 plus r. So let me write that out. So on the way, so over here, we're gonna have 450 and then plus r. And when the plane flies against the wind resistance will slow down the airplane. So now, what is going to be the rate of the plane when we fly against the wind? Isn't that nothing but 450 and then minus r? So I'm going to write that out. So this side we're going to have 450 minus r. So this was just a picture so that I can understand what the heck is going on. Now, when I do problems like this, I usually write down the chart just to keep it organized. So let me draw out the chart. Now the top box is the box for traveling with the wind, and then the second box is for traveling against the wind. And above it, all I did was wrote down the formula of motion. I think we're ready to fill this chart, so let's do it. Now, when we're traveling with the wind, the rate is going to become 450 plus r, and against the wind, it's going to be 450 minus r. And the next one, what was the total distance? Well, total distance was 4,000 miles, so I already know that, so let me just write that out. Now, let's deal with the time. Since we already know the rate and the distance, by using the formula d equals rt, do you see that we can solve the equation for time? So let me just write down what I'm talking about. So we already know that d equals to rt, where t stands for the time. So equation for the time is going to be d dividing by r. So you know what? What I'm going to do is to fill in those two boxes, I'm going to use this formula because we're already given distance and a rate. So let's go with the first box, which is traveling with the wind. So time should be d over r, but our d is 4,000. And then our r is 450 plus r. Now we're going to do the same thing for the second box. So here what we're going to get is 4,000 over 450 and then minus r. My handwriting is so horrible. I hope you can read this. The denominator says 450 minus r for the second box, and it says 450 plus r for the first box. So this is telling us that on the way to the conference, which is same thing as traveling with the wind, it took me this many hours. And then on the way back to my house, which is same thing as again going against the wind, the time that I travel is this much. But the thing is, what else do we know about the time? It took 10 hours for the round trip. So that means that if I add these two together, it has to equal to 10. So I'm going to write that out over here. And now I'm going to clean it up a little bit, and I'm going to write down what we just talked about. So going with the wind, it took me 4,000 all over 450, plus r, many hours. And then on the way back, it took me 4,000 over 450 minus r, many hours. But since the round trip was 10 hours, I'm going to have to set this equal to 10. So the most difficult part of this problem is done. Don't get scared because you see these huge numbers. Let me box this key equation that we're going to be using to solve this problem. Okay, now we're ready to solve this. So first, I need to get the common denominator of 450 plus r and 450 minus r. But since we're solving this equation, what we should do is multiply the left and the right hand side by the LCD, least common denominator. Well, what's the LCD? LCD is nothing but 450 plus r and then 450 minus the r. Alright, so what I'm going to do is multiply this side by that. And then also on this side, I'm running out of room already. So here I'm going to multiply by 450 plus r and then 450 minus r. Alright, now let's work it. So what we're going to have to do next is to distribute this nastiness to each term. Ready? We got this. So here what we're going to get is 450 plus r, 450 minus r, times the 4,000, whole thing divided by 450 plus r. And if I distribute the same quantity to the next term, what we're going to get is plus 450 plus r, 450 minus r, times by 4,000 all over 450 and then minus r. And on the right hand side, we're going to have 10 times 450 plus r and then 450 minus r. Yes, I know this looks completely nasty, right? But it's not as bad as you think, because can we not cancel something here? I think so, because look, 450 plus r goes away and then 450 minus r goes away. So it looks a little bit more simpler now. So now let me rewrite this. So we got 450 minus r times the 4,000, no more denominator, hooray, and then plus 450 plus r times the 4,000 equals to 10, 450 plus r, and then 450 minus the r. I'm trying to do this by step-by-step method, so please be patient. And to simplify the left-hand side of the equation, yes, of course you can distribute the 4,000 to each term, which is 450 in r, or you can think of it as factor the 4,000 out of there. So I don't know, whichever you want to do it is okay, but let me just be a little bit clever and factor out the 4,000, because look, what are those two terms having in common? 4,000. So I could do this. 4,000, and then the rest of it is going to be 450 minus r and then plus 450 plus r. If you didn't see it this way, totally fine. Just distribute that 4,000 and combine the like terms and you'll still get the same answer. Now, let me just try to explain what the heck I just did here though. Okay, so if I have something like, let me see, where can I write this? X times 4,000 plus the y times the 4,000. Can I not factor out the 4,000 and then combine the rest of it, which will be x plus y? Instead of x, I have 450 minus r, and then instead of a y, I just have 450 plus r. It just looks nasty, that's all. But anyways, let me just copy the other side. Now, before I do that, I could use another little shortcut, because look, can I not apply the difference of two square formula to this? Because remember, if I have a plus b and then a minus b, isn't this same as a squared minus the b squared? I think so. So take your a to be 450 and then b to be just the r. So if I apply the difference of two square formula, then I can rewrite this as 10 times 450 squared and then minus the r squared. Now let's keep simplifying this. So here I'm gonna have 4,000, and then inside of it, since there's a plus sign here, you're gonna get the same answer if you drop that parentheses. So you're gonna have 450 minus r plus 450 plus r, and on this side you're gonna have 10 450 squared minus the r squared. Okay, so let's work on here to get 4,000 times 450 plus 450, that will give us 900, and then our r is going to cancel. And on the right hand side, I'm still going to have 10 times 450 squared minus r squared. Next step, sure, you can distribute the 10 to each side if you want to, but look at it. Isn't 10 going to 900 very nicely? So to use another little shortcut, what I would do is to make my life a little bit simpler by dividing both sides by 10. Then what's going to happen? I could say 900 divided by 10, that's going to become 90. So I'm going to rewrite this as 4,000 times 90. It's just a little bit simpler looking, equals to 450 squared minus the r squared, because we're dividing by 10. And let's keep going. Yes, we're going to keep going. We're not going to give up. Alright, so let's first multiply 4,000 times 90. That's, what is that? 36,000? Alright, equals, oh yikes, 450 squared means 450 times the 450. We got this. Let's do it as a side work. 450 times 450. So first, if I multiply the zeros, I'm going to have a 0. Next, 5 times 0 is 0. 5 times 5 is 25. 5 times 4 is 20. Add 2, that will be 22. Now I'm going to multiply 4 times 0. And then 4 times 5 is 20. And then 4 times 4 is 16 plus 2, that will be 18. Alright, now I'm going to add 0, 0, 5, 2, 0, and then 2. Okay, see? We can do that. So this is going to be 450 squared is going to be 202500, and then we got minus the r squared. Now since we're solving for r, let's first get rid of this humongous number here by subtracting it to both sides. And what do we got? I think it's negative 198,900. Can you please double check my work? Equals to negative r squared. Now dividing by negative 1 on both sides. And here my claim is that our r squared is 198,900. To solve for r, we can apply the square root property. So what we're going to get is r equals to plus or minus the square root of the humongous number. But we're talking about the speed, so speed cannot be negative. So which means that we're only going to be taking the positive side of the square root of this nastiness. Yikes, I guess from here we're going to have to use your calculator to get the approximate value, but you know me, I'm all gung-ho about doing everything by hand, so I'm going to do it. And of course you're probably going to ask me, do we have to do this on the exam? Well, if I'm going to put a problem like this, please use your calculator. I will allow you to use your calculator, because this square root value is not going to turn out nicely, as you'll see. So let me just break it down. Well, for sure I know that 100 is going to go in, and then the rest of it I'm going to have 1989, and then this is going to be 10. Remember, we're looking for perfect squared, so we got 10 squared already, so I'm just going to leave it the way it is. Now for the 1989, is 3 go in? I think so. 3 times 6, 3. And then I guess another 3 can go in. 2, 2, 1. Okay, now 2, 2, 1. 2 is not going to go in. 3, no. 4, no. 5, no. 6, no. 7's not going to go in. 8 is not going to go in. 9's not going to go in. 10 is not going to go in. 11, no. But you know what? I think 13 goes in, doesn't it? 13 and then times 17, I think. But anyways, those are prime numbers, so we're just going to leave 221 as is. Well, let me just try to rewrite this. So we got this crazy number equals to 10 squared times the 3 squared times 13 times 17, which cannot break it down any further. So I'm just going to leave it as 221. So let's go back over here. So that implies that we're going to have r equals 10 squared times the 3 squared, and then 221. So we're going to have r equals 10 times 3 times the square root of 221. So what do we got? Looks like our speed in exact value is going to be r equals 30 times the square root of 221. Yikes. But you see what we just did? We can do this. We can do everything by hand. Well, pretty much everything. But anyway, since this was the word problem, let's answer our question in sentence. So therefore, what did r stand for? R was the speed of the jet stream, wasn't it? So I'm going to say the speed of the jet stream was 30 times the square root of 221 miles per hour. Now, if you type that in the calculator, let me just find my calculator first. Where in the heck is my calculator? Okay, here we go. I got 30 times the square root of 221. That's approximately equal to 445.982. So I would say 446. So this is approximately 446 miles per hour. And I'm just going to box that for the answer. Now let's take a look at a problem like this. Dr. Nak is having a pool party and wants to fill her pool. If she only uses the small hose, it takes 3 hours more than if she only uses the big hose. If she uses both hoses together, the pool will fill up in 2 hours. How long does it take for each hose to fill the pool? Alright, so let's do this. What is the question asking us to find? It says at the very bottom, how long does it take for each hose to fill the pool? So there are 2 hoses, small and big. Now let me try to underline the key words. So it says that if she only uses the small hose, takes 3 hours more than the big hose. Now let's translate that in mathematical notations. So first I'm going to say this. Let x be the number of hours for the big hose to fill up the pool. Before I do anything else, let me make a little chart just so that we can keep our information organized. Here's my chart. It separates into small hose, big hose, and then all together. The first column is for the number of hours needed to fill up the pool, and the second column is for the part of job completed per hour. Now let's start filling in the chart. So what do we know? We're letting x to be the number of hours for the big hose to fill up the pool. So this portion is going to be x. Now let's reread the problem again. It says small hose takes 3 hours more than the big hose. So this should be x plus 3. And it says that together, if I use both hoses together, the entire pool fills up in 2 hours. So here we go. And now let's deal with the second column. Second column is for the part of job completed per hour. The job meaning fill up the pool. Now let's think about this. So suppose that it's gonna take us to fill up the pool would be 5 hours. 5 hours. Then per hour, how many part of job have we completed? Isn't it just 1/5? So the same idea applies here. Instead of 5, I got x plus 3 going on. So the part of job completed per hour by the small hose would be 1 over x plus 3, just like 1/5. And for the big hose, we're going to do the same thing. It's going to be 1 over x, and then all together, I'm going to put it 1/2. So the part completed by the small hose plus the part completed by the big hose must equal to the amount completed together. So let's translate that into an equation. The work completed by the small hose was 1 over x plus 3, and then plus the work completed by the big hose was just 1 over x. Now all together it's 1/2. So this is the equation that we need to solve. So let me just rewrite it as, I'm just rewriting it. Okay, so now to solve this, we should multiply everything through by the least common denominator. So what's the LCD? Well, that's x plus 3 and x and then 2, isn't it? So I'm going to write it as 2x plus 3 and then x. Or you can just go 2x quantity x plus 3. It doesn't really matter. So let me multiply both sides by the LCD. Then here, let me just rewrite it like 2x and then x plus 3, same thing. And then I'm going to multiply here by 2x times the x plus 3. Okay, now I'm going to distribute this to each term. Alright, so then what we're going to get is 2x times x plus 3 over x plus 3, and then plus 2x times x plus 3 whole thing over x equals, now here you're going to have 1/2 times 2, so that's going to cancel each other out. But if you don't see that right away, that's fine. Let me rewrite it as 1/2 times 2x times dx plus 3. Alright, so now let's cancel what we can. So I could cancel this, I can cancel the x. Now you see I can cancel that too. Now let me just go on to the next page, and I'm going to clean it up. Then we should get 2x plus 2 times x plus 3 equals to x and then x plus 3. Alright, now let's keep going. Now I'm going to distribute this 2 to each term to get 2x plus 2x plus 6 equals, now I'm going to distribute this x to each term to get x squared plus the 3x. Alright, so now what can we do? I think we can still keep going by combining the like terms. So here what we're going to get is 4x plus 6 equals x squared plus 3x. Alright, now let me see, what can we do? Let's bring everybody on the left hand side or the right hand side. Either way is okay. So let me just go minus 4x to get 6 equals x squared and then minus x. Then I'm going to bring the 6 on the right hand side by subtracting 6, so we get 0 equals x squared minus the x minus 6. And we get this quadratic equation. So let me see, is that polynomial factorable? I think so. Let me see. If I put a xx plus minus, how about 3 and a 2? Does that work? Is 3 times 2, is it 6? Yes. Alright, so let's just double check. So first term, it will be x squared. And I have minus 3x plus 2x. That will give us negative x and then minus 6. Alright, this works. Okay, so that implies that either x plus 2 is 0 or x minus 3 is going to be 0. So this implies that x is negative 2 or x is 3. Let me just box both of them. But now let's go back and see what x stands for. Well, if you go back, wasn't it x equals the number of hours for the big hose to fill up the pool? So could that be negative? Can hours be negative? No. So we need to throw that one away. So the only keeper would be this. So again, this number is the number of hours for the big hose to fill up the pool. And if you go back and read the problem again, remember the small hose is going to take 3 more hours than the big hose. So in this case, our small hose will take x plus 3 hours to fill up the pool. So in this case, since our x is 3, what we're going to get is 3 plus 3, which will give us 6 hours. Now let's try to write this in a sentence. So I'm going to say it will take 3 hours for the big hose to fill up the pool, and it will take 6 hours for the small hose to fill the pool. And this is gonna be our answer. Alright, I think this is enough. We went over several examples, different kind of examples, so hopefully you can follow this work. And I do understand that a lot of us don't like word problems, but you see, you can do it. So great job everyone once again, and I will be talking to you soon.